We are going to discuss about cantilever beam with uniformly distributed load and point loads. The method of calculating bending moment and shear forces will be discussed. And after calculating the bending moment and shear forces, we will be drawing the bending moment and shear force diagrams. Let's start our work example. As you can see here, there are three segments in this beam. One segment is the segment that we have a uniform distributed load. The segments we have a point load, and there are two segments with no any other loads. So we consider each segment separately to calculate the bending moment and shear forces. First we consider the part with uniformly distributed load. There we consider x distance from the edge. Then we can calculate the maximum bending moment, right? So this is the bending moment here, right? We can take moment about this point, then we can calculate, because these two moments are in opposite direction. So therefore m equal 5 into distance is x, 5x, then multiplied by x by 2, that is the distance of the resultant force. So moment will be 5x squared over 2. Now let's see the moment at this end and this end, right? X equal 0. What's the bending moment? M equal 5, x is 0 divided by 0, this will become 0, right? When x equals 2, here at the end of the uniformly distributed load, we can calculate the bending moment. What's the bending moment? M equal 5 into 2 square divided by 2, that is 10 kilonewton meter. Now we have complete one segment. This segment, now we know the bending moment and shear forces. We know the variations also. It's a x squared, that is not a linear variation that we can use to plot the bending moment diagram. Then we consider the segment in between the point load and the UDL. Okay. Now let's calculate the bending moment there. Right. That segment also we better separate from the previous one. Then you have a moment like this. This distance will be 2 meters. This distance will be x. We consider x from this edge. Now we calculate the bending moment. Here we have a 5 kilonewton meter load. Kilonewton per meter load. Right? M equals 5 into 2. That's the load. Now need to calculate the distance. What's the distance? Total distance will be x. Then here to there x minus 2 plus x minus 2 we know from this distance is x minus 2. Then we have to add the load center, distance of the load center, that is 2 by 2, right? 2 by 2, right? If you solve this equation, this here it's 10, here x minus, here this one will be 2 by 2 is 1, here minus 2 there, then x minus 1. So we know the bending moment there. M is equal 10x minus 10, right? Now calculate the bending moment at the starting point of the end of the UDL and the starting point of the point load, that is when x is equal to 2 meters. What is the bending moment? M equal, this is become 20 minus 10, that will be 10 kilonewton. Previous also we calculate that value as 10, we can see here the same value. Then our calculation also seems correct. X equal 3 meters, that is where the point load is applied, right? Then here the 3, then 10 into 3 is 30, 30 minus 10, that will become 20. So now we know the bending moment at the starting end of the point load, end of the UDL and this point load. Now let's consider the next segment, this part, variation of the bending moment. Let's draw that part also separately. It will be easy for us to understand, right? This distance will be x, right? This distance will be this distance 2. What is this distance then? We previously also we calculated, right? X minus 2, right? You understood? We hope you understood. 5 kilonewton per meter load there, and we have a 10 kilonewton load here, right? Now let's write the bending moment equation. We know the bending moment. Here the moment equals 10 into, what's this distance? 10 into this total distance will be x, then here 2, this is 1 meter, that is x minus 3, right? Plus 5 into 2 multiplied by, now we did this calculation previously also, x minus 2 plus 2 by 2, right? Now what's the bending moment? Here we have a 10x minus 30 plus. Here what we get, previously that one we have calculated, that is 10x minus 10, right? Now we know the values of the bending moment. 20x minus 40. Let's see the bending moments at each point. When x is equal to 3 meters, that is where the point load is there. What's the bending moment? From this equation, m equals now 20x minus 40. When you put 20 into 3, that is 60. 60 minus 40, 20 kilonewton. Very easy, right? When x is equal to 4 meter, that is at support. What's the bending moment? 4. 20 into 4, 80. 80 minus 40, that's 40 kilonewton. Now we know the bending moments at each point. Now we can draw the bending moment diagram. Let's draw the bending moment diagram here. Okay. First we consider these 3 points. You have UDL there, we have point load there, right? Let's see, this is as the bending moment diagram. Then you have value like 10 there, 20 is there, then we got 40, right? We have a 4 meter beam, 3, 4, right? From edge up to this point, as we discussed previously, it's not linear variation. You reach to 10. From there, it's kind of a curve like this, right? From this point to the point load, that is a linear variation. You can see here it is a linear variation, 10x minus 10. So it's a linear variation. What's the value there? It is, we got as 20. This is a straight line, right? From that point onward, what's the variation? What's the value at support? It's 40. From this calculation we obtain it as a 40, right? Here we got the 40, and it's a linear variation, as you can see here, but the gradation is high, right? It's also linear variation is also high. So now I think you know the bending moment diagram. We have drawn the bending moment diagram. This is the bending moment diagram of that particular case. Now let's calculate the shear forces of the same beam and draw the shear force diagram. Let's calculate the shear forces of the beam. As discussed previously, we consider a segment we discussed previously from the x distance, right? We have 5 there. Now we are going to calculate the shear force V. We can consider the equilibrium there. V equal 5 into x. That is kind of a linear variation. So when x equals 0, V equal 5 into 0, that is 0. That's at the edge. It should be 0. That's okay. Then x is equal 2 meters. So here it's the 2 meters. Then V equal 5 into 2, that is 10 kilonewton. Shear force at here. Right, let's consider the segment in between 10 and 5 kilometer UDL. Right, that is section like this. You have 5 there. Then this distance is 2 meters. Now we are going to calculate V there. From the equilibrium, V equal 5 into 2. So the TC now, no variation there. Since this value is a constant, there's no variation with the distance, right? Even though this distance is varied from there, there is no variation. Now let's calculate the shear force in between support and the point load. Also we consider the same segment like this. We have a V, here we have 10, here we have 5. Distance there will be 2 meters. From the equilibrium, V equal 10 plus 5 into 2, that is 20 kilonewton. Right. Now let's draw the shear force diagram. First we indicate the load distribution there. We have point load like this, point load like this. Then we draw the shear force diagram. Now here we have a linear variation. Here shear force will be 0. Then up to a certain point, up to we check the shear force there. So value is 10. Okay, this will be increasing to 10. From this point onward, there is no variation, as we saw previously. There is no variation shear force diagram because it's a linear function, 2 into 5. What happened at this point? At this point, shear force will be increasing. That's because there is a point load of 10, right? This will be a 10. Then shear force will be like this. Here it should be 20. This value is 10 because we have a point load there 10. Then this should be downward. 10 should be there downward. Then this is a kind of horizontal variation. No change in the value. Then this will be reduced to 0. This is the shear force diagram. Right. I think you are now aware about the calculating bending moment and shear force of a cantilever. I hope that you gain certain knowledge on doing this kind of calculation. Let's meet again from similar kind of video. Thank you very much for watching our videos.